So now, guys, for in our NEET and JEE enthusiast phase, this is the chapter number second of kinematics. Okay, we have completed lecture number first of kinematics. Now we are starting. Uh, okay, the lecture number second. Okay, guys, for your information, you can visit our website. You can purchase our courses. You can download also our app from Play Store or iStore. Okay, you can purchase courses there, guys. Okay. It is very cheaper, guys. You can start your preparation without hesitation, without tension, okay? And go ahead to be a future doctor and engineer, okay, guys? So, without delaying, we are starting our lecture number two. So, now we earlier studied, okay, some basic definition of displacement, distance, okay, the acceleration, velocity. Now, we will discuss about today the equation of motion, okay, guys? So now guys we are starting the equation of motion with this topic, okay? So the first equation of motion we are talking about now, this time general equation. We are talking about general equation. The first equation is the velocity, okay? And that is termed as ds by dt. Is it okay, guys? The second equation, okay, the second equation is acceleration, okay, and the acceleration is dv by, and the third equation is again the acceleration, that is v dv by dx. Sorry guys, here ds will come. Okay guys, so this is the all three equation, or these are valid. Okay, these are valid valid whether acceleration is zero, either acceleration is constant, okay, or either acceleration is variable. Earlier you read the equation of motion v is equals to ut, u plus at, okay, we will discuss in later, at later. So this is the general equation of motion, okay. So now guys, also this is valid in all three cases, whether acceleration is zero, acceleration is constant, acceleration is variable. So now guys, again we are going forward for the to solve the problems, okay, so we can understand easily. Here look at this guys. Now a function is given xt, okay, this function is given, or here t is greater than 0, or x naught is greater than 0, okay. This x naught is a constant and this is positive constant. What question is asking, where does the particle start and with what velocity, okay. So where particle will start, okay, so I am putting simply t is equals to 0, okay. In this expression, when you put t is equals to 0 here, so this will comes out to be x naught already here, 1 minus, when you put t is equals to 0, see, gamma into 0, that will be 0. And you know guys, the e raised to power 0, that will be 1, okay. So this whole quantity will comes out to be 0. The particle will start from 0 0, okay, from origin. And the second part of this equation, with what velocity. So to calculate the velocity, what we have to do, we have to find out, we will derivative this, okay. So vt, that will be the differentiation of this function dx by dt, okay. Differentiate this, so that will comes out to be x naught 1. When you differentiate this, okay, this is the constant, x naught is a constant, and the differentiation of 1 is that is equals to 0, and here minus, or the differentiation of this function, that will be e raised to power minus gamma t into minus gamma. Okay guys, so the velocity comes out to be uh, gamma x naught e raised to power minus gamma t. Is it okay? So he's asking at t is equals to 0, the velocity will be, okay, when you put 0, though again this quantity is 1, so the velocity will be gamma x naught. Is it okay guys? Okay, at t equals to 0, at t equals to 0, okay guys, this is the t equals to 0, okay, this is a function of t, this is the style to return the function, okay. So t equals to 0, the velocity gamma x naught. Is it okay guys? This is the solution of part A. Is it okay? Now we are discussing part B. Is it okay guys? Find the maximum and minimum values of xt. So look at this guys, this is the exponential function, okay, exponential function. When you put t equals to 0, okay, this is giving the value x0. I'm talking about the first function, that is xt. Okay, or when you put t is equals to infinity, so this value, okay, remember this guys, when t e raised to power minus infinity will give the value 0. This is the additional information that is required in this question. So when you put t is equals to infinite, so that will becomes minus infinite, that will be 0. So one, okay, so this will comes out to be x naught, that is 1 minus 0. So this will comes out to be x is equals to, okay, that will comes out to be x naught. And now I am talking about the function vt, okay, the function vt, the function vt at t is equals to 0, t is equals to 0, the function vt. So this is the function vt. When you put t is equals to 0, this will be 1, the velocity will comes out to be gamma x naught. So this is the when put t is equals to infinite, so this is the minimum value of this function, this is the maximum value, okay. Or when put t is equals to infinite in this function, then it will become minus infinite, it will become 0. So the velocity will be 0. So guys, this is increasing with time. When time increase, x is increasing. Or here you can see, when time increase, this value is decreasing. Is it okay guys? This value is initially the velocity gamma x naught, but when time increasing, time infinite, the velocity becomes 0. Okay guys, and the acceleration, now we can see this is the periodic motion. So in periodic motion, where velocity is 0, the acceleration will be maximum. Or we can see through the expression. So we will calculate, this is the velocity. So to calculate the function acceleration in terms of t, that will be the differentiation of this function. Okay, when you again differentiate this, so this will comes out to be minus gamma square x naught e raised to power minus gamma t. So at t equals to 0, okay guys, again this is the maximum value, or this is the minimum value. Okay, this is the minimum value, or this is the maximum value. Okay, so t is equals to 0. When you put here, so this will be 1. So this will comes out to be acceleration minus gamma square x naught. When you put t is equals to infinite, you can see the acceleration will be, this terms will be 0. The whole term will be 0. So you can see guys, this value is increasing when some value from minus to 0, okay. In number line you can see this is the 0, this is the positive, this is negative. When value is increasing in this direction, it means the overall function is increasing. So you can see the acceleration is increasing when time is increasing. Okay, the acceleration increasing when time is increasing. Okay, guys. So again, this is the minimum value, this is the maximum value of acceleration. Is it okay, guys? So this is the related to basic function of mathematics. So guys, to start the physics, first go through our lectures of basic mathematics, otherwise it is very difficult. Now we are looking another problem. Okay, this is the problem of J. This velocity is given in the function of x along positive x-axis. Calculate the speed of the particles at t is equals to tau. The particle is at origin, t is equals to tau. This is the initial boundary condition. So now guys, we have to calculate speed. So we will convert this equation into in terms of time. So guys, how can we return this? This is the v is equals to v root x. Okay guys, now what we have to do? So now guys, okay, we can write down v is equals to dx by dt. Okay, so now we separate terms in this way and we integrate. Okay, when we integrate from 0 to x, or here 0 to t, so this will comes out to be uh, the differentiation of root x, that will be x, sorry, integration x minus half plus 1 minus half plus 1, and that will comes out to be b t, and 1 constant will come. Okay, if you put limit, then constant will not come, but so remove this limit. Okay, it does not require. Okay, either you can apply limit directly, or you can take constant here. It is your choice. When you solve this, this will comes out to be 2 root x, here b t plus c. Now the particle start from t is equals to 0. When you put t is equals to 0 at origin, x is equals to 0 and t is equals to 0. When you put these values, the c will automatically come 0. Okay, this will become 0, this will become 0, c is equals to 0. So the final equation comes out to be, when you square both the terms, though, and then x is equals to will comes out to be b square upon t square divided by 4. But now guys, in this question speed is asking. Okay, so we will again differentiate with respect to time t. Okay, so dx by dt will comes out to be b square by 4, and the differentiation of t square, that will be 2t. This is the velocity v, and t is equals to tau. It is asking velocity. Simply put, here 2 is to cancel out. So t is equals to tau, that is, so b square tau divided by 2. Okay guys, so this is the velocity guys. So which answer is correct? Answer B is correct guys. Okay, so without drilling, we are going forward for the next one. The answer B is correct answer. Is it okay guys? Now for the next concept, that is, okay, so this is a very good problem guys. Okay, this is again very good problem. This is conceptual subjective part. Okay, but to build concept, it is very good problem. A monkey climbs up a slippery pole for 3 and the subsequently slips for next 3. Its velocity at a time is given, that is function of t 2t 3s minus t for 0 to 3 second, and for next 3 to 6 second, the function velocity function this. It repeats this cycle till they reaches the height of 20 meter. So the first question is asking, at what time is its velocity maximum? So I earlier told you guys, whenever you find out the maximum of a function, so you have to differentiate that function. Okay, so the we will differentiate this function. Vt is already given, that is 2t 3s minus t. Okay guys, So when you differentiate this dv by dt, that will comes out to be, we can write down this function in this way, guys. Look at this. When you multiply 2t out inside, so this will comes out to be, this will comes out to be 6st minus 2t square. Is it okay, guys? So here is not a 3s, guys. Here is 3 second. Okay, that is this as is second. Okay, 3 minus t. When you multiply this 2t into inside, so this function will comes out to be, that is 6t minus 2t square. When you differentiate this function, that will comes out to be 6 minus 4t. Okay, so at what time its velocity will be maximum? When you equals to 0, so time will comes out to be 6 by 4. Okay, that will comes out to be 1.5 second. Okay, so this time this function will be maximum. So the first question is at what time? So this time 1.5 second. Now the next question is asking at what time its average velocity is maximum. So this is the part A. Now we will calculate the part B. So guys, we know the average velocity is equals to its function, its total distance upon total time. So it is the another way to calculate the distance vt into dt. We know the integration v is equals to ds by dt. To calculate ds, that will be v into dt. Okay, integration, or here is time, that is time interval. So it is important formula for calculating when v is given in terms of time t, in terms of function. So this is the formula to calculate the velocity, that this total distance. Okay, from here 0 to 3 seconds. Okay, 0 to 3 second. Is it okay, guys? Now we know the vt is 60 minus 2t square. So we simply put here 60 minus 2t square or dt upon, here the time is given 0 to 3. So now guys, further solving this problem, when you integrate this portion, so this 6t square by 2 minus 2t cube by 3. The value is 0 to 3, here 3 will come. Okay, this is the expression for average velocity. So now, okay, so at what time its average velocity will be maximum? Is it okay, guys? So we are calculating the first the average velocity. So now guys, when you solve further, so this will comes out to be 3t square. Okay, here minus 2 by 3 t cube. When you put limit here, guys, so this expression will come. Okay, so look at this, guys. Okay, when you put limit, so 3 3 square minus 2 by 3 3 cube divided by 3. When you guys divide by 3, this will comes out to be 9 minus, okay, when you divide in this, that will 3 square, that will be 3, that will minus 6 upon, sorry, that this will come, and that will come to 3 meter per second. Okay, so this is the average velocity. Okay, guys, so now what is asking at what time? So we know the expression of average velocity for the velocity, that is 6t square minus 2t. Is it okay, guys? Now what I do, we will equals to this the expression of velocity. So we will equals to this time, this expression will be equals to this is the average velocity. Okay, so you can see this is the quadratic equation in terms of t. Okay, so we can arrange in this way: 2t square minus 60 plus 3, that will equals to 0. When you further solve it, this will comes out to be t is equals to minus b, that will be 6 plus minus b square, that will be 36 minus 4ac upon 2a, that will be 4. Here 6 plus under root, sorry, this will comes out to be, when you square this b square, that will be 36. Okay, so this is 36 minus this will be 24 upon 4. Okay, so in now in a root, that will comes out to be 12 upon 4. So here we can write down 4 into 3. Okay, so 2 will comes out to be outside. So 6 plus minus 2 root 3 upon 4. Okay, this is the time. Okay, when you further solve it, this time will comes out to be, when you divide by 2. So this when you take 2 outside, so this will comes out to be 3 plus minus root 3 divided by 2. Is it okay, guys? When you so is it okay, guys? So now, guys, that is time will comes out to be approx 9 by 4 seconds. Is it okay, guys? The time will comes out to be 9 by 4 seconds. So this method to solve these problems. Okay. So now the next problem is, the third question is, at what time is acceleration maximum in magnitude? Okay. So first we have to calculate the acceleration. Okay, and then we will go for maximum condition. Is it okay, guys? So we will again we differentiate. We already differentiate this function, that is 6 minus uh, 40. Okay, so this is the acceleration. So this will be acceleration 6 minus 40. Okay, so we have to maximize this function. So dA upon dt, we calculate, that will be comes out to be minus 4. We put 0, it cannot be 0. So okay, so guys, in this situation we cannot find out the maximum value of this acceleration. So what we have to do, we use another concept. So to find out the problem C part, so we know where the velocity is. This is the periodic motion. Okay, the equation of this is the periodic motion. Okay, and the for periodic motion where velocity will be 0, the acceleration will be maximum. Okay, so we simply put the expression of velocity is equals to 0, and that is 2t square, that is 60 square, 60 minus 2t square is equals to 0. Okay, I am taking here 2t is common. So 3 minus t is equals to 0. So t is equals to 0 and t is equals to 3 seconds. So the velocity will be maximum at, sorry, the acceleration will be maximum t is equals to 3 seconds. Is it okay, guys? Now for the last part, the problem is, that is how many cycles counting factors are required to reach the top. So guys, we have already calculated from 0 to 3 second. From 0 to 3 second, the monkey travel distance, that we have already, now this is the expression. This is the expression from 0 to 3 second. We have already calculated here. You can see in this expression. Okay, in this expression we have already calculated. So now, guys, 0 to 3 second, the distance we have already calculated. Or see, guys, here in this expression we have already calculated, this is the distance. Okay, and that is, when you solve this, this will comes out to be here 27 and minus this will comes out to be 18, and that will comes out to be 9 meter. This is the distance that is 0 to 3 second. Okay, so we will use directly this result to solve the fourth part of this problem. Is it okay, guys? Now to solve the fourth part, so we have already calculated from 0 to 3 second the distance, that is 9 meter. But for 3 to 6 second, the another expression is given. So we have to calculate it. Again, we will take integration. That will be from now the integration will be 3 to 6. Okay. And this is given, guys, this is given in such a way. Look at this. Okay, in the problem here. T minus 3, 6 minus t. Okay, guys. T minus 3 and 6 minus 3. Okay, come here. Here, sorry, t minus 3 and 6 minus t, or minus is outside, dt. Okay, when you further solve it, d is equals to 3 to 6, 8 minus 9t plus t square. Is it okay, guys? That is dt. When you further solve this, so s will comes out to be, when you solve this, s will comes out to be minus 4.5 meter. Okay, guys, so the net increasing, the net distance will be, net distance that monkey will climb, that is equals to 9 minus 4.5. Okay, in first 3 seconds he climbed 9 meter, then again slips for 4.5 meter, that will be 4.5 meter. Now what cycle? So cycle will be 20 meter total distance, or in one cycle he climbs 4.5 meter. Okay, that will comes out to be 4.44, and approximate 5 cycle will comes. Is it okay, guys? This is a very good problem, guys. Very good problem. Without delaying, we are going our next problem. Okay, guys? So till now, everything is okay. Now we are coming to the equation of motion for constant acceleration. Okay, so we already know the three equation, that is v is equals to u plus at. So always use this equation when the acceleration is constant. Okay, or the earlier equation that is for valid for whether acceleration is constant, acceleration is zero, acceleration is increasing or decreasing variable, it doesn't matter. But this is the very important condition to use this equation. The first equation is v plus ut, and the second equation the displacement, that is s plus ut plus half at square. Okay, and the last, that is v square u square plus 2as. Is it okay, guys? This is the three equation of motion. Okay, so when you go through problems, so you can easily understand the use of these problems. There is no hi-fi technique to understand this. Okay, you already know, you can derive. Okay, you can see the derivation in NCRT, no problem, guys. Okay, so this is the first equation, this is the second equation, this is the third equation. You know the terms. V is the final velocity, u is the initial velocity, as the displacement, v is the, again the final velocity, use the initial velocity. Acceleration here the important is acceleration is constant. That is very important. Use initial velocity. So this is the very important term, guys. Okay, and the v is the final velocity. So this is the basic equation of motion, that is very important. Now we will use, but in NEET or J examination, the examiner will not ask you the direct application of this equation. So he will, so we will try to solve questions we try problems so that we can understand the application of these equations. So here, one person sitting in the ground floor of a building notices through the window of a height 1.5 meter a ball dropped from the roof of the building. Crosses the window in zero point 0.1 seconds. What is the velocity of the ball? It is at the topmost point of the window. So now guys, look at this. This is the window. Okay guys, this is the window. You can see this is the window. Okay. So this is the topmost point of window. Or here, so this is the topmost point, this is the top, this is the bottom. So the time taken to reach to, sorry, the time taken from reach to here, that is guys zero point 0.1 second. Is it okay? So now, and someone is sees this scenario, okay? Someone, this is the observer. Is it okay guys? So assume that the velocity here, that is u, and we have to find out the topmost velocity. And finally, he crosses this in zero point 0.1 second. So and the we know the height of this window, that is 1.5 meter. Okay, the height of this window, that is 1.5 meter. Is it okay guys? Is it okay? That is 1.5 meter. Okay. So assume that this problem, suppose that this is the initial velocity, this is the final velocity. With the initial velocity, okay, a ball covers 1.5 meter distance. Okay, so we will use the second equation of motion, that will be s is equals to ut plus half at square. So now use the, okay, now we will use the sign. Okay, so what I am taking, I am taking the all negative quantities in positive direction. So velocity initial, that is positive, the downward direction, gravitation is downward direction, and the displacement in downward direction. So I am taking all quantities in positive. So the displacement is 1.5 meter, and the initial velocity we have to calculate. Time is given 0.1 second. Okay, and the acceleration, that will be 10. We are assuming the gravitational acceleration value 10, and this will be 0.1 second, zero point 0.1 square. Okay guys, this the 5 will comes here, or when you further solve it, so this will comes out to be u is equals to 1.5 minus, that will be 0.01, so that will comes out in my 0.05 divided by zero point 0.1. Okay guys, that will be 0.1. Okay, when you further solve it, this will comes out to be, okay, that is 1.45 divided by zero point 0.1. Is it okay guys? 10 will come here, 100 will come here. This is a basic mathematics you can do. So the velocity will comes out to be 14.5 meter per second. Okay, so the answer B is correct answer. Okay guys, so the answer, the this problem answer is 14 point meter per second. Now guys, for the next problem, a stone falls freely under gravity. It covers distances h1, h2 and h3 in the first 5 seconds, and the next 5 seconds, and the next 5 seconds respectively, and the relation between h1. So look at this guys, this is the journey. Okay, a ball is going downward direction. Okay, a ball starts from here, coming. So now guys, this is the journey, ball start from here. So now look at this guys, in first 5 seconds the ball reaches here. Okay, Is it okay, guys? So this is the h1, s1 distance, or we can say this is the h1 distance. Now the ball is here at t is equals to 5 seconds. Is it okay, guys? Now for next another 5 second. Okay, for another 5 second. Okay, for another 5 second. Okay, so this distance is s2. Okay, this covered distance from here to here, that is here time interval is 10 seconds. Okay, this time is next 5 seconds. So again, so this distance from this point, that will be s2. Okay, guys, the distance, this is the a point, this is the b point. The distance from o b, that will be s2, and the h2 is the, we have find out h1 s2. This is the s2 distance. Okay, guys, this is the s2 distance, this is the h1 distance. It is also equals to s1 distance from the initial point. Now for the third interval, okay, again up to point C. Okay, this is the point C. Or here t is equals to 15 seconds. So in next 5 second interval, the distance covered, that is equals to h3. But from the initial point, the distance is equals to will be s3. Is it okay, guys? The distance will be equals to s3. Okay, this is the s3 distance from here to here. So we can easily calculate the s1, that is equals to initial ut plus half a t square. Okay, here the displacement is downward, the acceleration downward, so need not to be worried about saying the initial velocity is 0. So s1 will be comes out to be, time is in first 5 seconds. So okay, so I'm taking, guys, a by 2, I'm taking a by 2 taking as a constant, that is k. Okay, so simply t square is 5 second, t is equals to 5 seconds, so this will comes out with 25k. So to understand the problem, I am taking a by 2 is equals to k. This a by 2 will be k. Now for s2 distance, okay, from this is the s2 distance. Okay, this is the, don't confuse, guys. Okay, s2 distance, this is the s2 distance. Okay, or this is the s3 distance. Is it okay, guys? Or this is the s1 distance. Okay. Now as to distance, again a by 2 is constant, t square in first 10 seconds, that will be 100. T square is 100k. And for s3, that is t equals 50 seconds, then 15 square, that will be 255k. But question is asking travel distance in that is h1 s2. Okay, that will here 255, the 15 square to 55k. So h1 will be first 25k, and s2 will be this s2 is the s2 minus h1. Okay, guys, so h2 will comes out to be, s2 will be, we know, 100k, and s1 will be 25k, that is comes out to be 75k. So this is the h2, this is the h1. Similarly, we will find out the h3. This will comes out to be s3 minus h2. Okay, sorry, this will comes out to be s3 minus s2, not h2. Okay, guys, or this h not will h come, this will come, okay, this will come s1, which is equals to h1. Okay, so s2 minus s1, this will comes out to be s3 minus s2. S3 we already know, that is 255k, and s2, that is 100k. So this will comes out to be 125k. Is it okay, guys? When you take ratio of these distances, that will comes out to be h1 is 25k, s2 is 75k, and the last one is 125k. Okay, guys, when you divide by 25, that will comes out to be 1 raised to 3 raised to 5. Okay, so this is the very important, guys. Okay, so this will be in odd ratio. Okay, or again we can write down here this in such a way that is h1 upon 1. Okay, we can write down in this way also, that will be h1 upon s2 upon 2 s3 upon 3. Is it okay, guys? So answer B is the correct answer. Okay, so it is again very good problem. So now without delaying we are going for next problem. Okay, this is the very good problem, guys. This is the very good problem of J. Okay, you have to use some concept. So now that is the different rather than others. So a ball is thrown upward with an initial velocity v naught from the surface of the earth. The motion of the ball is affected by a drag force that is equals to m gamma v square, where m is the mass of the ball and v is its instantaneous velocity and gamma is a constant. Okay, so v is instantaneous velocity, that is variable, guys. Okay, up to top point the velocity will be 0. Look at this, guys. Okay, when you throw one ball some velocity u, this will go upward and then will come out downward. Okay, so here the topmost point the velocity will be 0. Is it okay, guys? But here the acceleration, one acceleration is gravity, that is the will act downward direction. But the drag force, okay, drag force always act in opposite direction of motion. Opposite direction of motion. Is it okay, guys? So again the drag force acceleration will comes. I am assuming the acceleration drag force due to drag force, that is A. Okay, will act also downward. So the net acceleration in this body, that will be A plus G. Is it okay, guys? So the net acceleration this. Okay, so this is the drag force. So the acceleration will be F by m, force upon mass, and this is the z, and this is the net acceleration. Okay, we can write down the net acceleration, that is dv by dt, and the force, drag force, that is m gamma v square upon m plus g. Is it okay, guys? So this will comes out to be dv upon dt, that is equals to gamma v square plus g. Up to here there is no problem. Now again the integration will start, because here velocity is variable. So now we will take integrate. So we separate these terms. This will, guys, dv upon v gamma square plus g upon dt. So we integrate these terms. Okay, guys. So the initial velocity will be v naught and that will be 0. Okay, and the time will be 0 to t. Okay, and the acceleration, that will okay, that will act in downward direction. So that will be minus sign will come out here. Okay, so this is the minus, here minus will come. Okay, so this minus will balance, this minus is balanced by this from v naught to initial velocity to 0 velocity. Okay, so what how we solve it now, guys? Important, this is the important formula. Okay, whenever you see this type of function, the integration of this function, that will be equals to 1 upon a tan inverse x upon a. Okay, so this is the additional information. If you don't know, it is very difficult. Otherwise, very easy. So we have to find out the time. Okay, so we will focus on integration, guys. Okay, so what I am doing, okay, what I am doing, guys, I am taking gamma square outside. Okay, this is the V gamma square. Is it okay, guys? V gamma square. So here, guys, you can see. Sorry, guys. Here, this is the note gamma square. This is the gamma V square. Is it okay, guys? What I'm taking gamma outside. Okay, that gamma here V naught to 0. Okay, and that is dV upon V square upon Z upon gamma. Okay, or I'm writing down this in root or square. So this is when you compare this format. So the integration of this format will comes out to be this. So that will be gamma. The integration of this minus sign valence. Okay, this is minus t. So this will comes out to 1 upon a. The a is root. The value of a is that is root gamma g upon gamma. Okay, and the tan inverse x upon a. X, that is velocity, and a is root g upon root gamma. That will comes out to be, this is the time. Okay, when you further solve this, the time will comes out to be here gamma root gamma. So here root gamma will come. So this will comes out to 1 upon root gamma z and tan inverse v root gamma upon z. So this is the again very good question, guys. Okay, if you know the basic mathematics, that will create problem if you don't know. So the answer is will comes out to be, okay, this. Okay, the answer will be C, guys. Okay, so not C. This the answer is tan inverse. Okay, the answer is here, tan inverse. Is it okay, guys? Is it okay? Okay, root gamma upon g. We can write down this. This is the root gamma upon g. Okay, t is equals to 1 upon root gamma g tan inverse root gamma upon g into v. It is very important, guys. Now, without delaying, we are going for next problem. Okay, guys, a car is moving along a straight line with a uniform acceleration. It passes through 2 points. Okay, what is happening, guys? What is happening in this question? Look at this. This is the point P. This is the point Q. This is the midpoint. We say that is R point. So the velocity at this point, that is 30 kmph, kilometer per hour. Here the velocity is 40 kmph. Now the velocity at this point, we assume the v kmph, kilometer per hour. So the velocity of the car midway between P and Q. Okay. So the R is at midway. Suppose that this is the distance x, this is the distance x. So what we have to find out, we have to find out the velocity. Okay, so we have to calculate this. So now, guys, this is the x. So we will use the third equation. Okay, so that is v square upon u square plus 2a s. The s distance, that is x. So the initial velocity here, point P, that will be, guys, 30 square and 2ax. Acceleration is constant because uniform acceleration is given. So now what I am doing, okay, what I am doing, I am taking v square minus 30 square upon 2a is equals to x. This is the equation 1. Now for the second case, now the initial velocity v, the final velocity 40. So we can write down the v square, sorry, now the final velocity is 40 square. So 40 square is equals to v square. This is the initial velocity plus 2ax. So this will comes out to be 40 v square and minus 2x is equals to x. This is the equation 2. Okay, come. Okay, guys. So equal to these equation. So equation 1 is equals to equation 2. Why? Because x, the distance is same. This point is on midway. So we can directly write down v square minus 30 square upon 2a and equals to 40 square minus v square upon 2a. This can simply cancel out. Okay, so this will comes out. This will comes out to be here. Okay, so this will 2v square, or here 40 square minus 30 square. Okay, guys, so v square comes out to be 40 square minus 30 square divided by 2. Or remember this formula, guys, for your objective. When you ask midway formula, so this will comes out to be v1 square minus, sorry, when this terms will this side, so this will become, guys, plus. Okay, v1 square plus v2 square divided by 2. So when you solve this, guys, this will comes out to be, this is the 1600, this is 1900 divided by 2. So this is the v, or we will take under root of this. Is it okay, guys? So this is the general formula. When you further solve this will comes out to be, okay, this will comes out to be, okay, this is the 16 plus 9, that is 2500, that will, so this will 50 upon root 2. This is the midway velocity. Is it okay, guys? So now we are going our next problem. Okay, so till now everything is clear, guys. Now we are coming our next problem. Okay, so a car is moving with a speed of 40 meter per second, can be stopped after 2 meter by applying brakes. If the same car is moving with a speed of 80 kmph, what is the minimum stopping distance? What is happening, guys? Look at this. Okay, this car with a speed. Okay, this is the speed. Here speed is 40 kilometer per hour. Is it okay, guys? Now the car is stopped here. Here velocity will be 0 and the distance covered, that is 2 meter. So definitely the body will retard, the car will retard, and we can find out the retardation. That is v square u square plus 2as. The final velocity is 0. So the s distance, that is will equals to minus u square upon 2a. Is it okay, guys? So what we are doing, guys, we are deriving a general formula. Then at last we will put the value. Is it okay, guys? And for the next case, okay, and for the next case, suppose that the speed increase some factor. Okay, the speed is increase some factor. Okay, suppose that this is the speed v. I'm assuming this is the velocity v dash. Okay, I'm assuming the distance travel, that is n times of this distance. Okay, so acceleration is same, and the final velocity will be 0. So again, when you use this formula, so this ns will comes out to be, this ns will comes out to be, okay, guys, this ns will comes out to be minus n square u square. So now, guys, I am taking v dash is equals to n times of v. Okay, not n dash, not n dash. I'm taking v dash equals to n times of v. So what I am taking, the distance this time, that is covered as this. Okay, so using the again equation v square 2s, the final velocity is 0, the initial velocity n times. So the n square v square. Okay, and plus 2a s dash. Okay, so the s dash will comes out to be minus n square v square upon 2a. Okay, over here I am taking u square, that is same, guys. Okay, that is u. sorry, you can take u, no problem. This you can take u, here again u is equals to n u times. Okay guys, so n square u square, okay, this is the u. So you can clearly see guys, s dash is equals to n square upon s. So this is the general formula. So velocity, so the we can calculate the n is the factor by which the velocity increasing. Okay, so 80 upon 40, that will becomes to 2. When you put 2 here, so s dash will comes out to be 2 square, and the distance in first with velocity 40, that is 2. Okay, so this will comes out to be 8 meter guys. So remember this general formula, that is again important for objective point of view. But with the with basic approach, you can solve this question. No need to be remember so many formulas. Go with basic approach, guys. Easily you can solve the problems. Okay. So the additional formula for constant acceleration. So that is important, guys. Okay. So for constant acceleration, okay, or when the body is going in straight line. Okay, guys. Suppose that this is the velocity u, this is the velocity v, and the body is going with acceleration a. So we can take average velocity, that will comes out to be v plus u divided by 2. Is it okay guys? So the distance, that will be v average into time. So this is the again in case of constant acceleration. So where it will be used, you can see some problems guys. Okay, in this problem, look at this. A particle moving in a straight line with a constant acceleration. Okay? It changes its velocity from 10 meter to 20 meter while passing through a distance. Okay, the value of time t. So again, we can take the average velocity, that will be 10 plus 20 divided by 2, that will be 15 meter per second. Is it okay guys? And the distance, that is 135 meter. So the time is distance upon velocity, that will be average, that will be 135 upon 15. So this will comes out to be guys 9 seconds. So this is the again basic approach to solve these problems. Now guys, in ns second, the distance travel in ns second, look at this guys, carefully look at this diagram. Okay, this is the t equals to 0, or this is the time t is equals to n second. Okay guys, now again this is the okay. So again this point is t is equals to 0, and this point is t equals to n minus 1 second. Okay guys, so the in ns second, the distance will be, remember guys, look at this carefully. Okay, so this is the distance which is covered in ns second. Okay, this is the distance. So we can write down the distance in ns second, that will be the distance in n second minus the distance in n minus 1 second. So this is the general formula guys. It is valid in any case. Okay, this is valid in any case guys. It is very important. Okay, this is valid in any case, whether acceleration is constant, acceleration is variable, acceleration is 0. This is the important formula guys. So this is the formula for ns second. Okay guys, so now we are going next. Okay, look at this problem. Okay guys, So we will use the basic formula. If the distance traveled by the a particle is given by this function, find the distance traveled in third second. Okay, guys. So simple. We are approaching. First, we find the distance in third second. That will be put directly third year from 3 year plus 2. Sorry, time is given 3 seconds. So this will be 15 plus 9 to the 18. This will comes out to be 33 meters. Okay. Or now guys, n minus 1, that will be 2. So put 2 here. 5 2 plus 2 square. So that will comes about 10 plus 8, 18 meter. Is it okay, guys? So now the distance covered in third second, okay, which is equals to 33 minus 18. Okay, guys, so that will comes out to be 15 meter. Okay, guys, this is the distance covered in nth second. Is it okay, guys? Now we will see the distance covered in nth second. Okay, for now we are talking about this in case of constant acceleration. Okay, guys, now this time the acceleration is constant, so that is not difficult. Again, same, we are using for n second, so that will be u, initial velocity u, t, that will be n second. I am taking n second, plus half a n second n square. Is it okay, guys? This is the distance in n second, and the distance in n minus 1 second, that will be u n minus 1 plus half a n minus 1 whole square. So the distance in nth second, that will be Sn minus Sn minus 1. So simply what you have to do, guys, minus the equation 1, this is the equation 2, minus these two equations. Okay, so I'm simply mining in this way. Okay, un minus, when you guys multiply, this will comes minus un, and this minus and this minus, that will comes out to be plus u. Is it okay, guys? Now again, I'm doing this a by 2, I'm taking common here. Inside n square minus n minus 1 square. So here is cancel out. So it will comes out to u plus a by 2. So this is the a square minus b square. So we can write down a plus b or a minus b. So a plus b. Okay, this is the a plus b. And this is the a minus and a minus b. Is it okay, guys? So here 1 is remaining. So here 2n minus will comes. Okay, so the distance in nth second, that will be u plus a by 2, 2n minus 1. Is it okay, guys? So it is very important. Okay, okay, guys. So this is the distance covered in nth second. So now, guys, look at these problems. A small block slides without friction down an inclined plane starting from rest. Let Sn be the distance traveled from Tn minus 1 to Tn. So we have to find out this ratio. Okay, so Sn is the distance traveled from n minus 1 to n. So what is happening, guys, here? Look at this. Suppose that this is the 0, this is the n second, t is equals to n second. Okay, and this distance, that point will be t is equals to n minus 1 second. Is it okay, guys? So now we have to find out this distance. There's distance that is equals to Sn. So we can directly use this formula and blocks will start from rest. So initial velocity will be 0. So the last formula, that is u plus a by 2 2n minus 1. This is the formula for nth distance. Okay. Now for n plus 1. Okay, we simply put here n plus 1. So this initial velocity is 0. This initial velocity will be 0. So okay, this is n plus 1. Okay, guys. Replace this n with n plus 1. Is it okay, guys? So now the ratio Sn upon Sn plus 1 will comes out to be, okay. So this will comes out to be a by 2 2n minus 1 upon this will comes out to be a by 2. Guys, look at this. When you multiply inside bracket, so this will comes out to be 2n plus 2 minus 1. 2 minus 1, that is plus 1. So this is 2n plus 1. Okay, is it okay, guys? Here it is cancel out. So the ratio will comes out to be 2n minus 1 upon 2n plus 1. Answer C is correct. So this is the J problem. Again, it is a good problem, guys. So now we are moving our next topic. Okay, so for kinematics, guys, this is very important topic. Okay, if you have no idea these graphs, then it is very difficult to solve the problems. Okay, and oftenly that problems is coming in this graph. Okay, at this graph problems. To understand what is the graph, what is the nature of graph. First of all, we discuss majorly three graphs, that is position versus time, velocity versus time, acceleration versus time. Sometimes you will face some velocity versus displacement graph. Okay, or acceleration versus displacement curve. Okay, but that will be in rare case. Okay, or special problems. But generally we see these three graphs: position versus time, velocity versus time, and acceleration versus time. So we will discuss one by one, guys. So first we are discussing the position versus time graph. Okay, guys. So I'm making here four graphs, guys. Okay, what I am making. Look at this, guys. I am making four graphs. Okay, position versus time graph. Okay, or we can say displacement versus time graph. This is the again scenario. And the last one is third one is the third one is, sorry guys, sorry. Okay, the fourth one is, fifth one is, so look at this, guys. First of all, the graph is a straight line. Sorry, the graph is constant. Second case, The graph is a straight line. Third case, a straight line but in negative slope. Fourth case, fourth case, a parabola. Okay, or a curve. Is it okay, guys? Now we will discuss one by one. This is the position. This is the time. A sticker. Okay, a sticker. Is it okay, guys? So now you can see the position is not changing. Okay, so we know from the differentiation the velocity is equals to the slope of ds by dt, and ds by dt it is the slope of st curve. Okay, guys, so ds by dt that will give slope of st curve, that will give the velocity, and the area under st curve. Okay, suppose that this is the area under this is st curve, so that will give the, sorry, the slope this vertical will the, so it doesn't, sorry, area under st curve will not give nothing, that is not matter for us. So simply we go for slope of st curve. Okay, or slope we can say that is tan theta. Okay, so here theta is equals to 0, it means velocity 0, or here acceleration 0. Is it okay, guys? Now in this case theta is constant. Is it okay, guys? So it means velocity constant, acceleration, since velocity is constant so acceleration is 0. Here in this case theta is measured here. Here slope is negative, guys. So it means velocity in negative, or we can say opposite direction, or acceleration again 0 because velocity constant but in negative direction. Now look at this, guys. Okay, I'm talking about here the slope is changing in every point. I'm talking about this point. Okay, so at this point the slope in this direction. Okay, guys, at this point the slope in this direction. Okay, so if you take here, okay, and if you take here, so in this case, guys, suppose that this is the theta 1 or this is the theta 2. Okay, so theta 2 is greater than theta 1. The slope is increasing. Okay, the slope we represent slope through m. Slope increasing, that's why velocity will be increasing. Okay, so acceleration. Okay, so acceleration will be constant. Acceleration will occur. Okay, in this case, suppose that at this point slope is here, slope is here, slope is here, slope is here. Okay, so in this case, okay, slope increasing but in negative direction. Okay, slope is increasing. Here is theta is equals to 0. Here theta is minus 45. Okay, here is theta is minus pi by 2. Okay, so theta is increasing negative. Okay, so velocity increasing in negative direction. Okay, guys, so acceleration is negative. Okay, guys, and the another form of this graphs may be, look at this, guys. Another form of this graph may be, look at this, guys, look at this. Another form of this graph may be, suppose that, okay, guys, so this is the, So in this case, the velocity also decreasing. Okay. So in this case, velocity decreasing, the acceleration will be negative, or we can say retardation is occur. This is the ST curve. Okay, guys. In this case, retardation. So remember, guys, this is ST curve. In this, or this is showing retardation. Okay, this is showing in. This is showing retardation, guys. Okay, guys. Now, uh, look at this, guys. This graph is not useful. Okay, for you. This graph, remember this graph that will be concave downward. Okay, this will give the retardation. And this graph is very important. Okay, again remember this graph. Okay, concave upward. This is the acceleration. Concave upward. Is it okay, guys? Now we are coming velocity versus time graph. So again, this is very important graph. Okay, so we'll look at this. Sorry, guys. We analysis different graphs. Okay, so this is the different scenario of graphs. Now, guys, what you have to do? Look at this. Here we are making 5 positions. Okay, it may be possible there is different cases, but this is the common cases. Okay, if you know, you can solve the problems easily. So that this VT curve is very important, guys. Okay, you can convert VT curve into position time curve, or you can convert VT curve into acceleration time curve. It is very important. So one curve is here, same one curve is here, same one curve is here. Okay, same. Again, this is the concave upward and the concave downward. Is it okay, guys? This is the VT curve. Okay, guys, this is the VT curve. Now remember, the slope of VT curve, that is dv by dt, will give the, guys, will give the acceleration. Slope of VT curve. Okay, that will give the acceleration. Okay, and we know, guys, that the distance is equals to integration v dot dt. Okay, or we can say, guys, we can say the area, we can say, guys, the area under a VT curve. VT curve will give the distance, or will give the displacement. Okay, or distance, both. So in this case, what is happening, guys? Here is velocity constant. So the slope is 0, the acceleration is 0. Body is moving with constant velocity. In this case, theta is constant, means slope is constant. So acceleration is constant. Is it okay, guys? And area under this curve will give the displacement. Okay, will give the displacement. Is it okay, guys? Will give the displacement. Now, now this now this time theta is negative, so acceleration is negative and constant. This case of retardation. In this case, guys, slope is increasing, means acceleration is increasing. In this case, slope is decreasing, means acceleration is decreasing, guys. So remember these 2 points, very important guys. The first one is the slope of the VT curve will give the acceleration, and the area under VT curve, okay, will give the displacement or distance. Displacement or distance. Is it okay guys? So this is very important terms, okay. Now for the last curve, that is acceleration time curve. Okay, the last curve is, that is the acceleration time curve. Okay guys, now guys, the last curve is acceleration time curve. Okay. Sorry. Sorry guys, sorry. The last curve is acceleration versus time curve guys. Okay, so in this case, suppose that if acceleration is constant, okay, so this will not come oftenly, okay. In rare case it will ask, okay, suppose that this is the a, this is the time t. If this curves here, so acceleration here constant. Okay guys, but one important thing in this curve, that is area under this curve. Okay guys, area under this curve will give the change in velocity. Okay guys, will give the change in velocity. This is the important, okay, guys. For AT curve, this is the important. Okay guys, now we are coming to solve the problems. Okay, so now look at this guys. The acceleration of a cart at t is equals to 0 varies with time as shown in figure. Find the distance traveled in first 30 seconds and draw the position time curve. So it is very good question guys now. To solve this problem very fast, what I am doing, I am converting this AT curve into VT curve. Is it okay guys? I am converting this curve into AT curve into VT curve. Okay. So now guys, what is happening here? Acceleration is constant. Okay. So acceleration is constant, so velocity increasing. Okay. You can see the graph we have discussed right now. And here acceleration is 0, so velocity is constant. We have studied these graphs already in VT curve. And again, the acceleration is negative, hence velocity decreasing. Okay, so this is the VT curve. Okay guys, for different time intervals. Okay, so this is the time interval. Okay guys, this is the time interval. T is equals to 10 second. And look at this guys, this is the time interval for t is equals to 20 second. Is it okay guys? And this point is t equals to 30 second. Is it okay guys? Now we know the acceleration, that is constant 5, or here is also 5. So the slope will give the acceleration. Okay, so VT curve, we know the slope, that is 5. So we can calculate this point. Okay, we know the slope, that is 5, but that is a maximum velocity. Okay guys, this is the maximum velocity, that is Vmax. Okay, so we can calculate Vmax, that is Vmax upon the base will be 10, and this value is equals to 5. So we can easily check Vmax will comes out to be 50 meter per second. Is it okay guys? So this point will comes out to be 50. Okay, This is 50. Okay, and the velocity in meter per second. Is it okay, guys? Now he is asking the distance travel in first 30 seconds. Okay, guys. So what I'm telling you, it is very important. Suppose that the area of this, okay, this under this curve, that is A1, under this curve A2, and this curve A3. So whenever you ask distance, okay, so we will take the area. We will take the area modulus. We will take modulus of areas. Okay, area may be negative. So A2, A1, A2 plus A3. We will take modulus of these three areas. Is it okay, guys? And for displacement, we will simply take algebraic sum, okay, with sign A1 plus A2 plus A3. So now, guys, we can calculate the area A1. That will be equals to area of this triangle. That will be half. Base will be 10 and the height will be 50. Okay, that will comes out to be 250 meter. Okay, because the area will give the displacement. Somebody will ask, sir, area, the unit will be meter square. Guys, this the unit will not meter square. This will be meter per second into second. So meter will come out. So area A2 will be, this is the rectangle. So this 50, this width is equals to 20 minus 10, that is 10, and the height is 50. So this 50 into 10, that is 500. Is it okay, guys? Now the A3 area will be same, that will be 250. Is it okay, guys? So we can say that distance that is equals to, so remember these two formula, guys. Okay, so here the distance is asking, here distance and displacement will be same, but if graph this vt curve is in negative side, then you have to take you have to consider the negative sign also. Okay, but in distance you have to take magnitude only. So we can directly add 250 plus 500 plus 250, that will comes out to be 1000 meter. Okay, that will comes out to be 250 plus 500 and 250, that will comes out to be 1000 meter. Is it okay, guys? Now for position time graph. Okay, look at this, guys. Look at this, guys. Okay, now this is the point 0. Okay, at 10 second the distance covered, that is 250. Okay, so 250 comes here. Is it okay, guys? This is the 10. Here 20 second, the distance covered. Okay, the 20 second the curve will consider here and here. Okay, this total curve will consider. Okay, guys, so the area of this triangle plus this rectangular, that will comes out to be 750. Is it okay, guys? And up and 30 second the whole area will be considered, that will be 1000. Okay, so this point is 1000. Okay, so okay, when you join these points, so you will get a straight line. Is it okay, guys? So this is the position time curve. Okay, guys, is it okay? Now guys, again we are going for next problem. So now guys, this is the very good problem. So which of the following curves does not represent motion in the one direction? Okay, so this is the vt curve. Okay, the slope of vt curve in this direction, that is theta. This is constant, so the body in this constantly increasing velocity, so x. Okay, so acceleration will be constant. Again, this is the theta. So here is retardation, acceleration is negative. Here the velocity is increasing. Okay, so acceleration will be increasing. Now in this case, now guys, here velocity maximum, here velocity is zero. This is the harmonic motion. Okay, simple harmonic SHM motion. So what is happening here is mean position. Suppose that this is x equals to 0 and this is the x equals to a. This is the x equals to minus a. Okay, so some particle, okay, going first in this side, now going in this side, okay, and to and fro about mean position. So this represent this motion. Okay, this is again in 1D, but this cannot be 1D. Okay guys, suppose that, okay, this cannot be 1D. Okay, because at a particular time it gives the two velocity, it cannot be possible. Okay, here this is the t equals to, suppose that 10 second. Okay, it is giving two velocity v1 and v2. Okay, and the value of v1 v2 that is different. So this graph cannot be possible, guys. Is it okay, guys? So this is the logical question. If you know the basic idea of vt curve. So now again this is the vt curve, guys. Okay, so now we have to convert this vt curve into, sorry, this is the vx curve, that is different. Okay, this is the j problem, guys, good problem. Okay, now we have to convert this the n to x. So now what I'm writing down, guys, okay, this is the intercept. So the equation of from again basic mathematics, we will use the straight line equation, that is v upon v naught plus x upon x naught is equals to 1. Okay guys, so I am writing down in this way, 1 minus x upon x naught. So here v is equals to v naught upon x naught, or x naught minus x, or I'm writing down this minus v naught upon x naught, x minus x naught. Is it okay guys? So I'm taking v naught upon x naught, that is m, small m. Okay guys, so v is equals to minus m x minus x naught. Okay, that is we can easily see that this theta is more than 90 degree, so the slope will be negative. We already discussed. So this slope is negative, but when differentiate with respect to x, okay, so this m minus m, okay, and the differentiation of this is constant, the differentiation this will be 0 and this will become 1. So dv by dx will comes out to be minus m, and we know the acceleration is v dv by dx. Is it okay guys? So I'm directly write down the acceleration is we have already calculated, that is minus m x minus x naught. Is it okay guys? And we know the dv by dx, that is minus m. Okay, so a will comes out to be m square x minus x naught. So here you can see this, the slope of this ax curve, that will be positive. So guys, in this case the slope is negative, in this case slope is 0, in this case slope is negative, but in this case slope is positive. Okay, or here slope is that is slope which graph, ax graph. Okay, we can say that is theta dash. Okay, so m square is positive, so the answer 1 is correct fit. So now guys, for again the next problem is, okay, so that is one block, one ball. So again this is the j problem and this is the good problem, guys, remember this is the good problem. Okay, a ball is dropped from vertically from a height d. Okay, suppose that this is the height d. Okay guys, this is the height d, and it hits back and again go up to a height d by 2. This is the height d by 2. So suppose that the velocity here v, again we are assuming the coefficient of restitution that will be 1. Okay, there is no loss of velocity. Elastic collision, purely elastic collision, guys. Okay, so we have to find out the height. So now, guys, the height is here. This is the height d above the ground. This is the height d by 2. So first, when you go this side, so height will be decrease. Okay, when ball drops, so in this case height will be decrease. Okay, or we can say the equation of second equation of motion as equals to ut plus half gt square. Okay, so this will 0. So h, but we have to find out the relation between v and h. Okay, so we do not use this equation, we will use the third equation of kinematics, that is v square u square plus 2ad. Is it okay, guys? Sorry, 2ah, d is constant here, so that's why plus 2ah. Initial velocity is 0, so will comes out to be root 2ah. Okay, so this is the equation of parabola. Okay, guys, this is the parabola. So this parabola curve, the height will be, so this will not come. Okay, and this, okay, this will not come because first case the height decreasing, on second case height is increasing, but in this case the height is increasing in both the curves, so this will not curve. Again, in this case again the height is increasing. Okay, in both the case this will not come, so the first answer will come. Okay, in this case this is the parabola, so this straight line will not come, or in both case the height is increasing. In this case height is, again height is increasing. Okay, and velocity negative, but in first case velocity is negative, in second case the velocity is positive. Okay, guys, so the first graph will come. Okay, so this is the again very good problem. Is it okay, guys? So now, guys, this is that lecture number 2 for kinematics. Okay, guys, so you can start our preparation from our values point. Okay, and you can visit our website, you can download our app on Play Store, or you can start your preparation. Okay, guys, thank you, bye bye.